So far, we have tried understanding the algorithm and pseudocode behind the bubble sorting algorithm, right? In this video, let's quickly implement the same thing using C++ and validate whether we are able to sort the given array of values either in the ascending order or in the descending order according to our requirement. Since it is our first sorting related implementation, right? What I want to do is I want to create a folder inside the project that we have set up. So that folder is, let me just create one by the name sorting. So this sorting folder, I will basically write any of the sorting techniques that we will be discussing in the future, be it insertion sort, merge sort, quick sort, or selection sorting, and any of the dependent functions that we will be implementing, right? We will be storing them inside this specific folder called sorting. So in this folder, let me just create a new file called bubblesort.cpp. Okay, so in this file, let's write the bubble sorting implementation, and let me just close all other files and minimize the side navigation as well, and let me just pull down this terminal as well. Here first, let me just add the basic boilerplate code that we will need inside this file. Now what I want to do is I want to write a new class called bubble sort. Inside this class, what I want to do is I want to add the public method in which I will implement the bubble sorting implementation to sort the array of values in the ascending order. Okay, so whatever the function that we will be writing, right, we need to pass some array of values, right? For that, what I will do is I will use the vector for passing the array of values. For using that vector, first of all, I need to import it, right? So first, let me just include that vector library as well. Okay, I have imported it. Now I can use it. So whatever the bubble sorting function that we are implementing, right, it need to take the array of values. In the end, it will need to return the array of values in the sorted fashion as well. As a result, the return type of the function will be vector of type int, and let's name the function as bubble sort. Okay, this function will basically take the array of values, right? So that will be vector of int type, and let's just name the variable that we get that input array of values inside this variable arr. Okay, now what we need to do, we need to sort this array of values in the ascending order, and we need to return that array in the end. Now if you remember the pseudocode that I have explained clearly, right, as part of the bubble sorting algorithm, what we will do, first of all, we will start the comparing two adjacent elements right from the first element, and we will continue comparing those two adjacent elements till we reach the very last value. Once we are done with comparing two adjacent values for all the values of the array that we have, we will basically get the largest value in the array at the very last position in the array. And if we repeat the same logic once again, we will get the second largest value in the second position from the end of the array, right? So we need to repeat the same logic for the number of values we have in the array. For that repeating, what I will do is I will write one for loop. Let's just say I equal to 0, I less than, we need to run the loop for each and every value we have in the array. That means the number of elements we have in the array, which is nothing but the size of the vector that we have got. In each and every step, I'll simply increment I by 1. Now inside this for loop, we need to compare the two adjacent elements for all the values of the array that we have got. For that, I will write another for loop for int j equal to 1. I will explain why I'm starting with j1 in couple of minutes. And this j also we need to run till the very last element, right? Till that very last element, two adjacent elements needs to be compared. As a result, this loop also needs to run for all the values we have in the array, and in each and every step I need to increment the j by 1. If you observe here, I'm starting the value, I'm starting the inner for loop j from 1. Why I'm doing that is, basically inside this for loop we will basically comparing two adjacent values, right? If I start the inner for loop from index 1, I will be able to compare the index 1 and index 0. That means I will be able to compare the element at jth index and j minus 1th index. That's the reason why I've started the for loop from j to 1. If at all, if you want to start the loop from 0, you can start with 0 as well, but here we simply need to run till last value minus 1th position only. In this case, we will be comparing the jth element and j plus 1th element. But anyway, I'll be running from 1 till the last element. Here inside this for loop, what we will be doing, we will need to compare the two adjacent elements, right? And if required, we need to swap them. So for that, what I will do is, if at all the value at j minus 1th index is greater than the value at the jth index, that means we have the value at j minus 1th index and we have the value at jth index. The value at j minus 1th index is greater. Since we are trying to sort the array in the ascending order, this value needs to go till the end of the array. As a result, the smaller values can come before. That's the reason why, if this is the case, what we need to do is we need to swap the values. So I will create one temporary variable and I will try to store the value at jth index in this temporary variable, and after that I'll be filling the value at jth index with array of j minus 1, and in the end array of j minus 1 gets filled with the temp value we have. Okay, once we are done with the inner for loop, right, we would have pushed the largest element to the end. If we repeat the same logic once again by coming out of this for loop and incrementing the I, we would have pushed the second largest value to the second position from the end of the array. As a result, once we complete this entire logic, right, we would have sorted the array in the array itself. If you observe the logic here, we are not creating any additional memory. We are simply using the input array of values that we have got itself to compare and swap, such that in the same array itself we will get the entire array sorted. Once we get the entire array sorted, we need to return it in the end, right? So let me just do return ARR. Okay, now here we need to give semicolon after closing after giving the closing parenthesis for the classes inside the C++. So I have added that. That is one thing. That's it. Now that we have implemented this, let's just call this function and validate if it is able to sort the given array of values in the ascending order. For that, first of all, let me just define some array of values that we will be using, and let's just say the values are 1 minus 9, sorry, 10 minus 9, 12, 8, 2, 1. Let's just assume these are the values that I want to sort in the ascending order. Now we need to call this bubble sort function, right? This bubble sort function is there inside this bubble sort class. So first we need to initialize this bubble sort class, so that using that object reference we will be able to call this bubble sort function. For that, first let me just initialize bubble sort bs. From this bs object reference, let's just call the bubble sort function and let's pass the array of values that we have defined. In the end, this bubble sort function will return the sorted array of values, right? And let's just try to capture it in another variable. Let's just say result array. Okay, and after that, to validate this, let's just try to print the values that we have got in the result array, so that we will be able to print the values and we will be able to confirm whether we are able to sort the given array of values in the ascending order or not. For that, let me just write one for loop for I equal to 0, I less than result array dot size, and in each and every step I just want to increment by 1, and here I want to do cout result array of the element at ith index, and after printing I just want to give space, and once we are done with printing all the values, I just want to do cout, I just do the end line. Okay, now since we have already installed the CodeRunner library, what we can do, we can simply right click on the mouse and choose this run code option, or you can simply click on this run button as well. So if I click on it, if you observe here on the console, it is running the command for compiling, and it compiled and it ran the compiled file as well, and the output that you see on the screen is -9, 1, 2, 8, 10, 12. So we've called the bubble sort function and it sorted the values that we have passed, and in the end whatever the values that we have printed, right, if you see on the console, they are sorted in the ascending order. So whatever the array that we have passed, whatever the implementation that we have done, it is working absolutely fine for sorting the given array of values in the ascending order. Now to repeat the same thing for the descending order sorting as well, what I want to do is, let me just copy the entire function that we have written here and let me just paste it, and let me just rename the function to bubble sort descending order. Here we need to sort the given array of values in the descending order. So the entire logic will remain same. The only difference is, since we are trying to sort the given array of values in the descending order, first of all what we will do, when we compare the value at j minus 1th index and jth index, if at all the value at j minus 1th index is smaller, then only we will swap. So the only modification we need to do is, inside this if comparison, we simply need to change this greater than comparison to less than comparison. That's the only modification. Why we are doing this? If the value at j minus 1th index is smaller, since we are trying to sort the given array in the descending order, in the beginning all the values should be greater, right? If it is smaller, it should go to the end of the array. That's the reason why we are comparing if it is less than, if so we are swapping it so that the smaller values will be pushed towards the end of the array. Okay, so that is the only modification we have done to get the bubble sorting implementations in the descending order as well. Now let me just call this function as well just to validate. So here whatever the bubble sort function call we have done, I've just modified it to bubble sort descending order. And if I simply choose run option, if you observe here, the array of values have been sorted in the descending order. The largest value is 12, after that second largest is 10, 8, 2, 1 and -9. If at all if you want to pass some other values, let's just say 99, 23, 290, anything, you can simply pass and you can simply run the code so that we will get the descending order sorted array, which you can see on the console as well. Okay, so this basically completes the implementation of bubble sorting algorithm. Thanks for watching this one. In the next video, we will get started with the implementation of selection sorting algorithm.